What's wrong with UML? So, I mean, inherently there's nothing wrong with UML. It's really a lot about myths. So I was a big UML user when I started my career in about 96 until about the early 2000s. And we used UML for literally everything we did. Agile came along and many people threw away big design up front, which is mostly a good thing, but they also coupled UML with big design up front. So of course, both those things got thrown away at the same time. UML has bad reputation, the tooling's historically been terrible, and there's something about UML that seems to draw people into the detail. UML is a specification, it's 800 pages long, you don't need to use the entirety of it, but from my perspective, there's just not enough structure, there's not enough usage examples around using UML. And that's why a lot of people default back to standard boxes and arrows, ad hoc boxes and arrows type diagrams, which is why I kind of created C4 to fill that gap and provide some structure for teams who didn't want to use UML. So many teams don't have any architecture diagrams or documentation. And although that seems fine initially, and it's fine for small teams, as teams tend to scale, multiple teams across multiple countries, et cetera, really a lot of this is about scaling information, scaling knowledge. So imagine you have a team, you have tons and tons of code, you have a new developer joining the team. Day one is read all the code, go add a feature. That's a really hard thing to ask developers to do. So a lot of the pain points involve missing knowledge, lack of knowledge, misinterpreting how the system should work. It's long ramp-up times for new developers to become efficient and become productive on the code base. So yeah, there's a bunch of pain points I typically see, and really that's the sweet spot for diagrams and documentation. So the problem with all diagrams and documentation is if you keep them aside and apart from the code, they're going to drift out of date quite quickly. So I guess an interesting question here is like, how do you keep these things up to date? You've got two options. So option one is to generate automatically all of your diagrams and documentation from your source code. And this sounds wonderful and it sounds ideal, and I think this would be an ideal solution. However, there's not enough metadata in many of the programming languages that we use in order to generate meaningful diagrams. So example, you have 1 million lines of code, and maybe that's broken up into like 100,000 Java classes. If you find some tooling to reverse engineer your code base, you're going to get a class diagram typically of 100,000 boxes, 100,000 classes, and all the arrows between them. So you might be thinking, well, let's aggregate and group some of those concepts into bigger building blocks. So what you might call modules or components. The problem is there's a lack of metadata in most languages to say, hey, these 10 classes make up a component, so therefore the box on the diagram we want to draw should represent that aggregation, that single component. So that's one of the biggest issues with automatically generating diagrams and documentation from code. There's not enough metadata, and you have to provide some heuristics and rules in order to interpret and analyze your code base. It's possible, but it's effort. And there's a value equation to be considered here. You know, is the value we're getting out of these things worth the effort we're putting in? So that's option one. Option two is way simpler. Just keep it up to date. So this is one of the things I see a lot of teams struggle with, like, how do we keep our documentation diagrams up to date? Just do it. You know, if you're doing pull requests, if you're doing definitions of done for your tasks and work items, just add a line to the bottom. Have you updated the diagrams and documentation for this particular thing you've done, changed, added, or whatever? And then it's lots of small incremental changes rather than someone sitting around for 6 months after everybody disappeared writing like all the diagrams, all the documentation. So for me, this is just something you get embedded into your process. So when teams don't have a shared understanding, what will typically happen is you'll be in an architecture meeting and people will be using words like components. So they'll be using the same word, but they'll be referring to very different levels of abstraction. So something I've seen in my workshops, for example, part of my workshop is like, here's a set of requirements, break up into groups, go do some design, draw some pictures. And sometimes when teams sketch those initial diagrams, you'll have one person who's looked at the diagram and made an assumption that this is a set of components in a monolithic application. And then someone else on the same team doing the same design has misinterpreted that same diagram to be a bunch of microservices over a completely distributed architecture. And that's exactly the sort of miscommunication I see happen with teams in the real world. They're describing their architecture to, again, new joiners, they're onboarding new developers, etc. And they're describing their architecture in a way that doesn't make sense to everybody on the team. They don't have that shared ubiquitous language. So my talk today was the C4 model, misuses, mistakes, misconceptions. So I've been teaching C4 for around 15, 16, 17 years, depending on when you put the start point. And I've seen pretty much every way you can use C4 incorrectly. Some of the biggest misconceptions I see are that the blue and gray notation is boring. So in order to draw some example diagrams, I needed to create some example diagrams, and I chose some boxes and some colors, and I chose blue and gray boxes, and that's where that whole myth has come from. So other colors are available, other shapes are available, and you can also use UML as your notation if you want to. So one of the biggest misconceptions I see is that C4 is forcing people to use a specific notation. That's not the case, it's notation independent. One of the other biggest misconceptions I see is around things like microservices architecture. So how do we use C4 to describe microservices architectures? And it turns out there's not a straightforward answer, because a lot of it depends on your perspective. If you're one team creating a single software system that's comprised of a bunch of microservices, there's one set of approaches to do that. If we're doing the whole Conway Saw thing, and I'm building a microservice and you're building a microservice, we might treat each other's services as software systems, so higher level abstractions. So for me, a lot of the misconceptions are around the abstractions and understanding abstractions and using the abstractions properly. C4 is really just a formalization of how I used to draw architecture diagrams. The entire backstory is I used to run architecture workshops, and people were drawing architecture diagrams that I didn't understand. Nobody wanted to use UML. So I figured I'll just teach them how I draw diagrams, and that's kind of where C4 came from. C4 is actually named after the diagram types, the hierarchical diagram type. So it's a system, context, containers, components, and code. So that's where the C4 name comes from, because I think it's a much easier, snappier way to remember the types of diagrams that people might find useful to draw.